All right, thanks for joining us again, Chill Pills. Let's look at another certification exam prep demonstration. This is a similar question to what we've done before, only this stock label has two different concentrations I want us to evaluate. So let's look at the question. A prescriber ordered clindamycin 0.25 grams intramuscularly stat and then every 8 hours, just like our previous question. Although looking at the label, clindamycin typically is not administered intramuscularly, but the label says that it can, or it can be administered intravenously. More than likely, Cleocin is available in many doses, and they're available intravenously prepackaged. So more than likely, it might be administered intramuscularly for that stat dose, maybe, but rarely. It would more than likely be administered in the intravenous dose. But neither here nor there. Let's look at our question. This is what our question wrote. So the question is, doctor ordered 0.25 grams stat, but the dose on hand is milligrams, 300 milligrams per 2 ml. That is our stock vial dose. The total dose in this stock vial is 2 milliliters, 2 milliliter vial up here, and 300 milligrams total. It has a single dose concentration of 150 milligrams per 1 milliliter, per one single milliliter. So that is our single dose concentration, and our stock dose concentration, 300 milligrams per 2 ml. So that is our dose ordered. That is our dose on hand information. Back to our dose ordered, 0.25 grams. But our dose on hand is in milligrams. So we need to convert that grams into milligrams. So I have it listed here already, pre-filled. But again, remember your conversions. When we're going from grams to milligrams, we have to multiply by 1,000. 0.25 grams multiplied by 1,000 yields 250 milligrams. Let's set up our ratio proportion equation. 350 milligrams per 2 mLs, that's our dose on hand on our left-hand side, just like before. And our dose ordered on our right-hand side, 250 milligrams per unknown volume. We'll cross-multiply like before, and it yields 300 milligrams per unknown volume. Set it equal to 250 times 2 equals 500 milligrams per ml. We divide both sides of the equation by the 300 milligrams because it's with our unknown variable. This side divided by 300 milligrams, our 300 milligrams cancel out, only leaving us with our unknown volume in milliliters. Then over here, 500 milligrams divided by 300 milligrams, our milligram units cancel out. It only leaves us with our milliliter unit here. So 500 divided by 300 yields 1.6 milliliters. Let's also look at our single dose concentration. Our single dose concentration, 150 milligrams per 1 milliliter, set it equal to dose ordered, 250 milligrams per unknown variable. We'll cross multiply like before. 250 times 1 milliliter yields 250 milligrams per milliliter. Divide by what the value on the side with our unknown variable is 150 divided by 150. That becomes the number 1, and it leaves us with unknown volume. Set it equal to 250 divided by 150, 1.6 milliliters once again. Now let's also try our shorthand formula, dose ordered divided by dose on hand times 1 milliliter. We have a 1 milliliter concentration, and you'll see why here, why that 1 milliliter concentration makes everything better. We don't have to worry about the stock dose concentration. Dose ordered, 250 milligrams on top. Divided by dose on hand times 1 milliliter. Dose on hand, 150 milligrams times 1 milliliter, our single dose concentration. We multiply across our numerators, and we yield the exact same answer. But notice how it was much simpler with our shorthand formula, dose ordered over dose on hand times 1 milliliter. Still equals 1.6 milliliters. All right, That is it for this video. I hope you all enjoyed it and you could see how to solve it clearly. If you have any questions, please hit me up in the comments below. Check out our next video.